time around, we would like to specifically focus on firmware updates. And the idea is to collaborate closely with the OCP community to arrive at a standard way of solving this firmware update problem for the cloud. If you look at the guts of a real firmware update, it's a very simple problem. Actually, it is essentially a collection of reads, erase operations, write operations, and basically verify operations. Any firmware update you take. Then why is it so challenging for the cloud? If you take a compute node, it actually has a variety of components that attract various kinds of firmware elements. And one of the challenges is that some of these are maybe behind an SPI bus, some components are behind a PCI bus, some are behind an I2C bus, or maybe other various other interfaces like HECI or KCS, etc. That means that all these writes have to happen through respective bus interfaces, and that actually is one degree of complexity. But beyond that, how do we deploy firmware to a fleet of servers at a data center at a cloud scale? Then once you do all your updates, how do you know that a X cluster, Y row, and a Z node, how do you know that that compute node is prepared and ready for operation in terms of various firmwares and their versions, etc. So the conformance against design standards and design specifications is one challenge. How do we assess it is a challenge. Then you want updates to happen from time to time, and these updates should also not impact the availability of a compute node. In other words, updates have to go silent, without impacting end user context, that are happening, on a compute node. Then recovery is another thing. If updates fail, how do you guarantee recoverability of the node? These are the main challenges, right? So that's it. Now, in terms of one easy fix would be not to update firmware at all. But is that a possibility? The answer is no, because we have from time to time face bug fixes, performance improvements, or security, or various other reasons why we end up updating firmware. The other thing is firmware updates can happen either in band or out of band, and there are variety of provisions that are available today. Some can be assisted by Uefi. The other thing is maybe via an SMM, maybe an OS driver, whether it's Windows or Linux context. You have OS drivers that can talk to various devices. You can get your firmware updates done through that interface, or you can also have out of band means. Before I talk about that, I just want to talk a little bit about a nomenclature. We want to compartmentalize firmwares into two areas. One is system firmware. System firmware is anything that is mandatory for making the boot happen. And device firmware is anything that is kind of enabling platform extensions, but not necessary for a boot to happen. So maybe BMC, ME, or and BIOS, they are all can be considered like system firmware ingredients, whereas op-ROMs and other things can be considered as like system device firmware ingredients. No matter whether you want to do in-band or out-of-band, there are salient advantages and also some opens with each of the approach that we have today. Let's say Uefi provides API and envelope level definitions which are consistent across devices and systems. But one thing is, if you are doing Uefi, purely Uefi aware update, some of these are available only in boot service context, which means that the compute node needs to go through system resets, right? That is one issue that we have to probably solve for cloud somehow. Similarly, SMI, the advantage is through SMIs, updates can be silent, but the SMI handlers are typically available for SPI for devices behind SPI. But for other interfaces, maybe there is some work left to be done. There's an open if you go through SMI route. If you go through OS driver route, the updates are silent, but at the same time, there may be some scope for standardization there. Similarly, for out of band, there are challenges in terms of arbitration with the host context, and also there are some issues related to bandwidth. So these are the problems that we need to somehow solve. There are some advantages with Uefi today that we probably have to harness and take it to the next step. So given that, I would like to hand it over to Vincent.
Hey, thanks, Malik. So folks can also hear me. I don't know if that's a good or bad thing. Just kidding. So yeah, thanks, Malik, for giving the background on the ecosystem. And so what I wanted to do is, I work for Intel, but today I'm sort of representing Uefi Forum and some of our open source community on how we view updates. So EFI is a host-based firmware, the system firmware Malik mentioned. It runs on the host CPU. And Uefi is a standard about interoperability on host-based execution. So capsules, what capsules are a means by which to convey a bundle of information from the pre-OS or the OS runtime through an API called update capsule back into the firmware. As Malik said, this API can be implemented in SMM, but typically is implemented in a way that across a restart. So that's the API portion of capsules. Capsules, the principal use case is firmware update. It passes a binary blob that's essentially an envelope with many data items inside, which I'll talk about. And then the firmware, various entities in the pre-OS can parse it and apply updates. But sort of what I want you guys to take away from this first page is capsules are two things. APIs, things that are exposed on the host, through your host firmware, but then an enveloped set of data. So the envelope, we believe, is even more perhaps applicable than the API, because the API implies you're running on the host doing EFI, whereas the envelope is essentially a well-defined data item. So what does Uefi bring to the table for updates? I remember I saw someone on Twitter said, if you read the foil, why are you even there? So I try not to just read a PowerPoint to you guys. But the gist of it is the Uefi infrastructure defines a table of the updatable elements. So as Malik said, a lot of entities in the platform are updatable. Adapter cards, maybe little sensor driver, microcontrollers, and your host firmware. So the ESRT, EFI system resource table exposes at boot what these updatable entities are, and they're named by GUIDs. The capsule, that binary bag of data, has the similar GUIDs. And so what the ESRT tells you is what's updatable in my platform, and then you can curate a set of capsules to send to the platform. These capsules can be created by the system board manufacturer. They can be created by the device vendors themselves to update their entity. So EFI has the API, the capsule, through ESRT, a way to define what's updatable, an API called the Firmware Management Protocol. So an adapter card in the pre-OS can say, hey, send me a capsule. We added APIs like P7 Verify, so that if you're an adapter card and don't want to contain your own crypto, you can use the system board firmware. So essentially, there's a lot of infrastructure in EFI to facilitate the update scenarios. But now that we have all this infrastructure, how can we extend it? It's great for updating your system firmware, but again, what about updating other entities in the platform? Let's see where I'm at on my time here. Okay, try to close with 10 minutes for discussion. And I don't think I'm gonna reply to my instant messenger from Peach about what lunch do I want in Seattle today, since I'm a little far from Seattle. So, so again, really capsules, the ESRT tells you what you can update, an API to send a capsule, but then there's the envelope. And we think this again is sort of a pivot that can be more general beyond just the system firmware update. In this envelope, you have sections. These sections can have additional metadata, named by GUIDs, who's the vendor, sections that say it's compressed or signed. So essentially, it's an extensibility mechanism to say who is the entity to be updated, and then putting provisions around the update for data integrity and identifying from whom it came from. And the nice thing about Uefi, the forum owns just very few GUIDs, the generic header, but different vendors can define their own GUIDs, and then different standards groups can even stand up and say, hey, I'm OCP, and to update OCP style device X, here's a GUID and here's what we think a capsule should look like. Again, GUIDs are an open namespace that anyone can define their own. That's why we define our APIs with GUIDs, so people like the Trusted Computing Group can define their own APIs and data structures. Same here with capsules. This generic envelope with entities named by GUIDs can even be extended by other standards bodies, including OCP. And then in-band. Uefi is all about in-band. I'm running on the host, call this capsule update API, but a provocative thought, and I'm not an out-of-band service processor BMC guy, so I'm sure people in this room here will take your pitchforks and stab me, because Tom Slate's probably laughing because I don't know BMCs very well. But in my sort of poor man's BIOS view of the world, if I'm working with a vendor to create an update, why can't the same envelope that I pass through my host be passed across the network through a service processor? Again, we wouldn't ask the BMC community to expose EFI-like APIs because it has its own software architecture. But if you're doing a business-to-business interaction and asking a supplier to say, provide me an update, why can't that envelope be the same for updating my firmware, in-band, out-of-band, and perhaps even that same firmware could be used by an OS entity. So the one time I subscribed to the Linux kernel mailing list, they were updating their firmware update API, which was a way Linux drivers can get device firmware and apply it. Maybe again, having a common way that you could even have OS agents grab these firmware updates and apply them. So again, use the envelope for many things. Why ask an ecosystem to define data integrity and packaging models for operating systems, for execution environments? Why not reuse something that exists? So that's sort of some of the thought we wanted to get cooking here. Again, security is always a big concern. So you can have sections. We already have Uefi security with a known data integrity model. We have CA stood up, but that implies a PE cough. In the Uefi PI spec, we have definitions of envelopes for different signature mechanisms. But what if you want to add SVNs? What if you want to add provisions for golden image, i.e. this GUID means it's the golden, whatever. Using the generic envelope with GUIDs, you could add additional provisions for your use case. And maybe this is something that would be of interest to this class of market. So really, before we break into some of the Q&A, really what we wanted to just talk to you guys about are, is this sort of model make sense, right? Start using capsules for your more first-class host-based interface. To me, that's job one. And in some of our more information, we'll tell you what the Linux community and Microsoft have been doing to this end, and what we've been doing in our open source upstream. Does it make sense to have this as a general envelope for in-band, out-of-band, for OS drivers to use? And other things, node equivalence. So for example, this ESRT I mentioned, which is a data table you get when you boot, should this class of what is your inventory of updatable information, that sundry set of GUIDs, be exposed other ways? I do the network boot work in the Uefi forum. And one thing I'm very proud of since we talked last March was we added HTTP boot, so a discoverable network boot, and sort of a successor to Pixie, very much like what iPixie does. But in your discovery mechanism, you can have option tags. Maybe some of this information can be exposed as part of a network boot. Again, how can we make this more manageable for the data center guys? And then namespaces of GUIDs. Since this is an extensibility mechanism and different standards bodies or business entities can define their own GUIDs. For example, most vendors today define GUIDs for their own system board update. Maybe with OCP, you can define some well-known GUIDs for some scenarios where there needs to be interoperability. And really, I think the thing we want to, how do we drive forward? It's great to say all this exists, but how do we marshal some energies and effort? And really the discussion we want to have, and Malik and I are committed to work with OCP this year, and when it makes sense, other standards groups. Obviously, a standards discussion of other standards we can't have in the open here. We have to have in those respective locales, but come up with what we think what would an OCP spec on updates look like. And as a base case, the information we talked about today, what exists within the UEFI spec, in vendor and the operating systems and the open source upstreams, that would sort of be our base case. And then advocacies to ingredient providers like IHVs on how to curate their own updates. So we're thinking this year, 2016 could be the year of an OCP sort of firmware update spec. So even though our title said standard, big S, it can even be a little s, right? That just sort of points at existing art. But that's something Malik and I really want to work with the Hardware Management Forum and folks like you guys in the audience and the 2 people watching on the YouTube live streaming join in. And so I don't know about you guys, but when I see a talk or read a paper, I often go right to the references, right? It's like, okay, this guy gave a 10-minute spiel on something, but give me something more authoritative or something I can read deeper. And this is where we kind of bombed you guys with a bit of a mess here. But you guys know the first link, obviously, Open Compute, your landing page. The uefi.org/specifications has the UEFI spec with this information on capsules. Tiano Core has a reference implementation of a UEFI firmware, including capsule update driver. I believe our core platform actually has an instance of end-to-end usage. Firmware.intel.com, some white papers, including a blog where what we did, Malik and I talked both at the OCP this time last year and at the UEFI Plug Fest. The Plug Fest was able to talk about the 2.5 features like the network boot. So there's some information you guys can get caught up on that. And then I think really proud of, Microsoft really led the use of capsules inaugurally in Windows 8, and then the ESRT they contributed to the UEFI spec. I believe it landed in 2.4. So Mike, some collateral on how Microsoft from the operating system, you can apply capsules. And then some recent news of a blog post from Peter Jones of Fedora, the community-based code that feeds in the RHEL, how they have a FWUPD, a daemon, and exposure, and sysfs and other things, and curation of firmware updates that can be applied through Linux. So the Linux Windows ecosystem have support for this today. So this isn't theoretical. We've got upstream support for the generic code. Vendors are implementing it in product, OEMs, BIOS vendors, like one of them I'm staring at 20 feet from me. So this stuff is real. And what we'd like to do is, since people have laid the tracks, the bricks, the infrastructure for this, apply it for some of these cloud-based use cases, including but not limited to other management vectors like out-of-band or maybe even OS-based driver. And with that, I ran a minute over what I had committed. Leave 9 minutes for an open discussion. We'll bring Malik back to the camera. I don't know if the camera can see buttons.
Is mic live? Okay. Excellent. Switch. Anybody know where the switch is on this thing?
Why don't you ask a question?
Yeah. It's okay. There we go. So regarding security, you mentioned that there was support for signing, and I assume that's at the capsule level, or is that at a lower?
Yes. So the capsules, you can have sections, and the section can be an encapsulation section. Mm-hmm. So essentially, you can do, it's like the Russian nesting dolls. So you can have one of the outer nesting dolls as a crypto envelope. And so you can do your RSA 2048, SHA-256, or you could say, hey, I want to sell into the Far East and I need to do SM3 based. You can even define a GUID, but yes, you have a way to encapsulate this.
So that first portion is that one of the problems we face in out of band is that the updates may need to come down incrementally with the transfer, that is. And in a particular, we'll call it, say, capsule, you may have the updates for several devices. So one of the problems we've been looking at is the need for effectively a sort of a standardized manifest, where you sign the manifest, and the manifest has, let's say, the SHA-256 hashes of the components that follow. This lets you pull down a tiny manifest, keep it in your staging area, and then as the other modules come in, you can not only validate their integrity, but you can also validate that they are indeed part of that package. Yeah.
Okay. And is the model that the manifest is curated by the system board manufacturer, so it's under his authority, or?
Well, whoever is producing the package, but yes, it probably would be typically the system integrator or the system board.
So do you imagine a world of the system integrator doing the large envelope and then having integrity protected payloads inside for sundry entities?
Yeah, exactly. Let's say a typical system integrator, we'll use the famous name Contoso. So they may have firmware components from 3 different vendors, and they've only validated particular revisions of those updates. So even though individually those updates may all be accepted by the device, a particular combination you also want to.
Okay. So yeah, and I'd argue that's a problem enjoyed also by the host base, and I would think we could model this, using Capsule as a starting point. And I always say, not because we solved some problem in computer science better than the world, it's just what landed first and where has the ecosystem built tools. Yeah, I'd really love if we could try to work together on having a common envelope, and then you ingest it, vendor-specific BMC flows. One flow to ingest is through the update capsule API, but the good stuff is inside, right? To me, it's syntactic sugar on how you land it. Right?
Okay, thank you.
Nice.
Pass this around.
Yeah, we implemented integrated firmware update, and one of the methods we used is FMP before.
Okay.
And in theory, everything works fine, but in practice, there are a lot of challenges.
I've never seen that happen. Okay. Just joking.
One challenge we face, ultimately it led to customers giving up that feature, is there's no standard on firmware versioning. So FMP just says firmware version, firmware package version. And what we have seen is one vendor says genuine Uefi firmware, another one says 25.a.2.5.85. Another vendor uses 2 characters.
So
there's no standard.
Taxonomy and naming. Okay.
Right. So the problem we faced was the BMC was the one that stages the firmware update. So it has to keep track of whether it is a new update or whether it is a old version, new version. It has to compare, and then only it will allow whether to update or not. So there's no standard way for them to figure out by looking at the firmware version number given by FMP.
Okay, that's good.
So you guys have any effort going on to standardize that?
Yeah. So I don't know of a work item within the Uefi forum, but I think that problem statement is really good. And I would argue as we try to harmonize everyone doing updates, I would hope this would be the Venn diagram overlap. Because again, the thing I always worry about is you have an IHV that's building Silicon X. He's assaulted by the BIOS guys do something. He's assaulted by service processor guys. And let's just have one story to talk to them all. And so I think we could harmonize updates irrespective of the staging or delivery venue. But yeah, there's not a specific work item within the Uefi forum. I think that would be a great thing for this 2016 effort to try to crush. Because I think the best innovation is business driven, and that's a great business problem to observe.
When we attempted this about a year ago, we hardly found only 1 or 2 vendors that are actually supporting FMP. Most others are just supporting FMP, very basic mandatory function. I think get version or something like that. Okay. Nothing else. What's your take on industrial adoption?
Yeah, I don't have as much exposure to the IHVs. So the most success I've seen on updates, to be honest, is the the capsule based, and a lot of it I believe is for system board firmware. I don't have as good a feel for the IHVs on their how many are producing FMPs or even delivering capsules with their own update utility and or firmware assisted like the P7. I don't know. I don't have that data.
Because of these challenges, most vendors are trying to use MCTP and other channels to update the firmware instead of going through VAS FMP.
And you know what? And I'd argue sometimes a negative result is fine as long as it's informed and if there's data. And maybe that state of the art and directions is maybe that's the trend line. So I'm not a marketing guy for EFI. There's not a little bell that rings and I sold EFI to someone. I think that's that feedback and that market feedback as we try to reduce the spec to practice. I would hope at least the art that's in the market, like the host-based OS staged, how the Linux and Windows community, because in the UEFI world, we worry about, we never want an ecosystem party to deliver a security bug. But if they do, and it's perhaps been known to happen, go to tno.org/security. I wrote a doc there with an advisory. So when those bugs get out, we want to reduce the friction for people to push updates. We believe once you build the highway to push updates, not just for reactive to security issues, but maintenance actions, i.e. device updates. And then if you're doing it through the host, could you leverage the infrastructure for out-of-band? But if the out-of-band art is evolved enough and is separate, maybe this harmonization is not possible. Okay, that's fine. Like I said, I don't get an extra stripe on my, that's fine. Good feedback.
I have a real quick question. This has been you've talked a lot in very much detail about the low level of how the firmware updates are delivered, but I'm curious from an operator's perspective. I work on OpenStack Ironic, and so I'm curious how much standardization is actually going into the delivery method so that maybe we could have a standard way to update the firmware across of all Open Compute from like a host standpoint or a BMC standpoint, because I'll admit half of our code base is, firmware updates or things like that.
I might have to point to the big infrastructure guy. The oxygen gets thin the higher I go, and so my brain gets slowly.
So that is something that we want to solve here. That is the divergence that we see between out of band versus in band. And I think one thing we are emphasizing is if we can arrive at an envelope that is common across all these means, the scripting can be very easy in our website. So if we can arrive at that envelope, that's very first degree of
and I'd recommend surfing over to what the Linux guys did. There's actually a website where they're curating and collecting these. But if I'm an IT operator and I'm doing Ironic and data centers, I don't know what the workflow would be to write a bash script to say how to automate. I'm not smart enough on that, to be honest.
Another thing, let's say you have a compute node which is in operation and you want to push an update. Versus you take a blade for an RMA kind of scenario where you want to debug it or something. You don't want to throw different binaries for an EFI shell based update, a Windows update. So that's one way to solve this problem.
Another question I have about security is you talk a lot about signing when you're getting the firmwares in. Is there going to be something built into the standard to pull the firmware back out so that if, let's say, you've handed over the machine to an untrusted person and then you want to verify when you get it back that the firmware is the exact same that you gave it to them?
Well, that's a good question. Typically, we have other sort of audit capability like measured boot where you could look at the log. But yeah, marrying sort of the measurements and your updates, I don't know if they're tightly coupled. That's actually a good use case. So,
Yeah, we can talk afterward.
okay, that's a good one. Yeah.
So,
You need Mike?
yeah. Okay. So there will be Uefi forum under the you want to say that? Right? So we want to solve these problems collectively with the OCP community. So there'll be maybe a bi-weekly cadence, some meetings discussing these issues. So I would encourage you all to participate in that.
I work with rack based on metal. So we take OpenSCAPE machines and give them to read users who don't trust them. Want a sticker? You would use it. Aaron. We find the ability to pull the firmware out and get it from kind of a true sense of a hardware level. It's useful because you want to not only prevent that from happening, but to actually almost one of our customers could break a machine to the point that those networks have breathed out the temperatures. And so, like for us, we very much are trying to detect malicious behavior more so than verify the thing. Because we have other ways to verify the thing you're saying. We care about did the user violate
All right. Our next set of speakers are from Facebook. We have Sai, Sari, and Tian, and Ruben. They will be talking about OpenBMC. So obviously last year we talked OpenBMC. There is a lot of development since then. I don't want to steal that thunders, but it's in the GitHub, and we will talk about what happened since last year. Okay.
Thank you. Okay, my name is Pian. Today, so